Today we're going to fully performance test this 120 volt 16,000 BTU Fogatti RV air conditioner to see how well it actually cools, how much airflow it produces, how many watts it consumes, and how efficient it really is. Now, one reason this Fogatti AC is interesting is because it offers some features that may appeal to RV owners beyond just cooling capacity. This is a 16,000 BTU 120 volt rooftop RV air conditioner that also includes a 12,500 BTU heat pump along with directional swing vents and a more modern design compared to many traditional RV rooftop AC units. Today I'm specifically focusing on cooling performance, airflow, power consumption, inverter efficiency, and off-grid operation. But while setting up this test, I realized there was another really important part of the conversation that a lot of people overlook when trying to run a 120 volt RV air conditioner off-grid. Most people assume that if they purchase an inverter, they can suddenly run their RV AC from batteries. But what many people don't realize is that the inverter is only one part of the system. Your batteries, wiring, voltage, inverter efficiency, heat, and overall system design all play a major role in whether an RV air conditioner will actually run properly and safely off-grid. And one of the biggest mistakes people make is never actually looking at their battery specifications. A lot of people simply assume that all lithium batteries are capable of handling high inverter loads, but that is absolutely not the case. Battery discharge ratings matter, and today's testing really surprised me. I was actually to get this group 24 Redodo 12 volt 100 amp hour battery to run this 16,000 BTU 120 volt Fogatti RV air conditioner, but there was a problem. The battery was pulling over 110 amps continuously and operating above its rated specifications just to keep the AC running. So in addition to fully performance testing the Fogatti RV AC, we're also going to compare multiple battery and inverter combinations and measure real-world inverter efficiency to show what really matters when trying to run a 120 volt RV air conditioner off-grid. So let's get started. For the first test, I connected the Fogatti RV AC to the Redodo 2000 watt inverter using this Group 24 Redodo 12 volt 100 amp hour battery. To monitor what was actually happening, I installed a Victron shunt between the battery and inverter so I can measure the real power being pulled directly from the battery. The inverter was delivering around 1,125 watts at 118 volts to the AC, but the Victron showed the inverter was actually pulling around 1,335 watts and about 110 amps directly from the battery. Now that's important because this battery is only rated for 100 amps continuous discharge and about 1,280 watts continuous output. So even though the AC technically ran, the battery was already operating above its continuous specifications. I also noticed the battery starting to warm up during the test, so I shut everything down before pushing it any further. In my opinion, this is not a setup I would personally run continuously because ideally you never want to rely on the battery's BMS protection system as your primary safety margin. This test also highlights something many people overlook when trying to run a 120 volt RV air conditioner off-grid. At 120 volts, this AC is only pulling around 9 to 10 amps on the AC side. But on the 12 volt battery side, the inverter is pulling over 100 amps continuously. Now that's a massive difference. Another thing people often overlook is that the inverter itself consumes power during the DC to AC conversion process. So even though the AC is only receiving about 1,125 watts, the inverter is actually pulling around 1,335 watts from the battery. That extra 200 plus watts is mostly being lost as heat during the power conversion process. That's why inverter efficiency matters, especially during large continuous loads like running an RV air conditioner off-grid. And this is exactly why wiring size, battery discharge ratings, fuse sizing, and connection quality becomes so important in an off-grid RV system. High current creates heat, voltage drop, and additional stress throughout the entire system. So next, I moved to a much larger battery setup using the Renogy 240 amp hour semi-solid state battery. This battery is capable of 240 amps continuous discharge, making it much better suited for a heavy inverter load like an RV air conditioner. First, I tested the larger Renogy battery with the same Redodo 2000 watt inverter to see where the AC would stabilize in power draw and to measure real world inverter efficiency. The Victron shunt showed me the inverter pulling about 1,384 watts and 108.88 amps from the battery at 12.71 volts. Meanwhile, the inverter was delivering around 1,180 watts at 118 volts to the Fogatti AC. That works out to about 85% inverter efficiency under this load. The important difference here is that I'm still using the same Redodo 2000 watt inverter. The only thing I changed was the battery. With the Redodo 100 amp hour battery, the AC technically ran, but the battery was operating above its rated specifications. With the Renogy 240 amp hour battery, the current draw was still high, but now the battery was operating well within its continuous discharge rating. Voltage sag also improved compared to the smaller battery setup, which is exactly what you would expect from a battery designed for higher continuous current loads. Next, I switched over to the Renogy 3000 watt inverter using the same Renogy 240 amp hour battery setup. This time the Victron showed about 1,345 watts and 105.66 amps coming from the battery, while the inverter delivered about 1,182 watts at 120 volts and 9.85 amps to the AC. That works out to about 88% efficiency, making the larger Renogy inverter slightly more efficient during this test. Now that we've tested both inverters using the same Renogy 240 amp hour battery, we can directly compare inverter efficiency. The Redodo inverter came in at around 85% efficiency, while the Renogy inverter was closer to 88% efficient. That may not sound like a huge difference, but when you're running from batteries, every bit of efficiency matters because wasted power becomes heat, and heat is the enemy of electrical systems. I did experience the Renogy inverter shutting down once after running the AC for around 15 minutes in approximately 93-degree weather while continuously pulling around 1,350 watts from the battery. The inverter was hot to the touch and began beeping before shutting down, so heat may have been a contributing factor, although I can't say for certain that thermal protection caused the shutdown. And that's another important reminder that inverter size alone is not the entire story. Ambient temperature, airflow, battery voltage, wiring, and continuous load all matter when running an RV air conditioner off-grid. Now that we have a stable power setup, let's fully performance test the Fogatti RV AC and see how it actually performs from a cooling and efficiency standpoint. For the AC performance test, I measured an inlet temperature of 93 degrees and an outlet temperature of 70 degrees for a 23-degree temperature split. Airflow came in at an impressive 539.5 CFM, and the maximum AC side power draw was 1,188 watts. Using the measured airflow and temperature split, the Fogatti produced approximately 13,400 sensible BTUH during testing. That gives this setup an EER of approximately 11.28. One thing I really liked during testing was the airflow performance of the Fogatti AC. At nearly 540 CFM, this thing moves a lot of air, and airflow matters because even a cold evaporator coil won't cool an RV effectively if the system can't move enough air through the coach. Strong airflow helps distribute cooling more evenly and can make the RV feel more comfortable faster. And with over 13,400 sensible BTUH measured during testing while staying under 1,200 watts, the Fogatti actually delivered pretty respectable performance. Overall, the Fogatti AC performed well in testing with strong airflow, respectable cooling performance, and reasonable power consumption for a 120-volt RV air conditioner. And in addition to the cooling performance, this unit also includes features like a built-in heat pump and directional swing vents that some RV owners may find attractive. But the bigger takeaway from this video is that running an RV air conditioner off-grid is about much more than just inverter size. Battery discharge capability, inverter efficiency, wiring, heat, and overall system design all play a major role. A properly sized system is what really matters. If you're interested in any of the products used in this video, check the description below for discount links. If you enjoyed this video and want to see more real-world RV AC testing, inverter testing, and off-grid power setups, make sure to hit that like button, subscribe, and as always, stay charged!